This video is going to look at a special binomial product expansion. I'm going to do an example here of a binomial product expansion that I'm talking about. So if I have, for example, y plus 5, y subtract 5, and I expand it like my binomial products video, I get y squared, subtract 5y, add 5y, subtract 25. If I look for my like terms, there's my like terms, and they in fact cancel each other out. So those like terms cancel each other out, and my answer is y squared subtract 25. So if we can recognise this, we can do a shortcut, we can go straight to the answer, because this is a special type of product. Let's look at our answer. There's two terms. There is a difference in the middle, this being the difference. This first term has a square root. It's called a perfect square. It has a square root. The square root is y. This second term is also a perfect square. It has a square root 5. So if in our brackets initially, look at our brackets initially, what's in the brackets is exactly the same except for the sign in the middle. If what's in the brackets is exactly the same except for the sign in the middle, our answer is two terms, a difference in the middle, and the perfect squares. We square this first term here, square our y to get y squared, and square our 5 to get 25. Let's look at the first example that the textbook has done. X plus 8, x subtract 8. So yes, this is one of the special types of binomial products. What's in the brackets is exactly the same except for the sign. So we can do a shortcut. We're going to end up with two terms, a difference in the middle. The first term is we square this. The second term, we square the 8. So it's really good for us to be able to recognise these patterns. So this is the pattern if it starts off exactly the same in the brackets except for the sign. Let's look at our next example. What's in the brackets again is exactly the same except for the sign. So we end up with two terms with a difference in the middle. The first term, we square the 6. The second term, we square the x. Example C. Let's look at what's in the brackets, and yep, again, they're exactly the same except for the sign. So applying our rule, and this is the difference of two squares rule. Difference, our first square, we square this, 2x squared, 2x, and we square it gives us 4x squared, and then we square the 3 to give us 9. So we get a difference of two squares, in other words, a difference of two perfect squares. Our last example. Let's look at what's in the brackets. Yep, what's in the brackets is exactly the same except for the sign. Okay, so if you can't recognise that it's exactly the same except for the sign, let's look at this first bracket. There'd be nothing wrong with changing the order around. So I've just changed the order around of those terms, kept the second bracket the same, and then I think you can see that it is exactly the same except for the sign. So the difference of two squares rule applies. We're going to end up with two terms. Difference in between. Let's square the first term, and let's square this second term. So our difference of two squares rule, it works. If what's in the brackets is exactly the same except for the sign, we end up with two terms. Two terms, a difference in between, the square of the first term, subtract the square of the second term. That is our difference of two squares rule.